with the blood. We have gotten down to a tube. Does everybody kind of see this tube? What do you notice about it? Are we still in a structure that is strict and cartilaginous? Do you see any of those cartilage C-rings?
No.
No. I am now at the level of the tube, okay, that is pretty much smooth muscle. Oh, wait a minute, do what? Wow. What could possibly happen at that level? What could possibly happen at this level where the air exchange occurs and the tube that I'm looking at is now pretty much smooth muscle? We're going to have it expand and contract. What happens with people with asthma?
Doesn't it just stay constricted?
Yes. This is the point that a person with asthma is suffering. Because at this point, that tube is here, okay? And so the air is not moving. Medications that they use are working at this level. They're working at this level to try to help people who suffer from something such as asthma. So, as we move down those tubes, and we're at the bronchioles, and we come into the bronchi, branch, if we work our way back, okay, we've got our alveolar sacs. They go into a duct, and we're moving our way back towards the bigger tubes. So bigger to smaller, and then smaller back out to bigger for this structure. At the point where things are going to get interesting is at the point of the alveolus. One of the sacs, one of the grapes. Okay. Couple of things to note. When we are looking at the structure that is located, we're going to find that we have something called the respiratory membrane. This becomes very clinically significant in different cases. All right? This membrane serves as a barrier between the air in an alveoli and the air, well, the bloodstream. So if I'm looking at my structure up here, looking at one of the sacs, okay? Do you guys remember how I said that when we get into these tissues, they don't have the ability to be great at getting rid of foreign pathogens? They do not have a huge supply of white blood cells. It's just not present. Some of these cells that are going to be present are going to have some different functions that will be present. Okay, we're going to get into those. But what we're trying to look at right here is the area of my respiratory membrane. So if I'm taking that shot and looking at it right here, this would be that part of the sac this would be the blood vessels. And what they're trying to represent in between is my respiratory membrane. Basically, this area between the two, and it's fluid-based. Wow. Huh. Let me think here for a second. It's fluid-based. Can these gases that need to exchange dissolve or move through a fluid?
No.
They have to be able to. They have to. Or else we wouldn't have movement. But wait a minute. Any of y'all going into respiratory therapy? Okay. You're going to get to know this really well. Are you taking anything right now? Are you taking like Rest 101 or
I'm
anything?
gonna take that next semester, yeah.
Okay. Okay. Because I was going to say, if you were taking it now, you'd already know about this.
Yeah.
You would already know about this membrane. Because one of the other things you're going to have to know a whole lot about are the gas laws. Okay, so, are you going into rest? Okay. What becomes important is for, first of all, one of the things that's going to happen, we know that we're going to need to get the CO2 out, because CO2 for us is toxic, okay? Now, oxygen, well now wait a minute. Everything we've pretty much talked about has been how important oxygen is, okay? But see, here's the thing. CO2 is going to dissolve very easily in a fluid. We know that because we drink soda, we drink carbonated water, we drink carbonated stuff. And it's carbonated because it's carbon dioxide. Okay? Now, do y'all ever drink an oxygenated drink? Wonder why. Y'all ever seen the okay, at a drink machine, and you got the structure of the drink machine, and it's got the little wires coming off of those cylinders. Those cylinders, okay, those cylinders are CO2, okay? And the little tube, this is how it was back in the old day. I think they've kind of gotten a lot of the stuff out of it. Anyway, okay, so now, basically the tube is reaching that CO2, bringing it into the fluid, and making it all bubbly. The fizzy bubbly. Okay, so we end up with that carbonated drink. Did we ever see that with the oxygen tube? Cylinder?
Nope.
No. So based upon that information, which one of these gases is dissolving more easily? CO2. Which means CO2 will move easily from the blood to the sac to be breathed out. Oxygen, we got to control a little bit more. And because okay? That red blood cell, which is our only way to transport oxygen, all right? That hemoglobin molecule is the only way. It may not have dropped off but one oxygen. That hemoglobin can hold up to 4. It may have only dropped off 1. I need to make sure that in this exchange that occurs, I don't get more oxygen moved than it can carry. Does that make sense? Okay. This respiratory membrane, sometimes children can be born with some breathing issues because the cells that are present, like for example, those little cells up there, pneumocytes, okay, which are the cells of the lungs, okay, one of them produces something called a surfactant. Do you happen to know what a surfactant is? And Marlisha, this is going to come in a lot where if you're going into rest. What's a surfactant? There used to be a lot of them and cleaning products that we used to buy, but they found out it wasn't the best thing to be putting into the water systems. And it makes stuff slippery. The cells that are found here produce something that makes this membrane slippery. I wonder why. Why would I need for it to be slippery between the sac and my blood vessels? So that I don't create friction. That these can be this close together and still have a separation that doesn't make every time we breathe, okay, cause friction. Sometimes babies can be born and the breathing problem they have is that in their lungs there's no surfactant. So their lungs have not inflated. And they'll usually come in, give them a shot, which is basically surfactant, and helps their body get that production, and then the body usually takes over and that's fine.
The respiratory system, pretty much one of the last things to develop for fetus.
Yes.
So I guess maybe why.
Yeah, because see, up to the point that all the other development is occurring, the respiratory system is being taken care of from mom. All right, so it doesn't really focus on it. It's focusing on building the brain, the nervous system, the bone. That well, most of it's cartilage, but you know what I'm saying. It's working on the other stuff. So this helps create a little bit of slipperiness to be present, and helps those lungs move smoothly. When we look at this cavity that the lungs are located in, okay, so we all know we've got our heart.